Today, I will introduce DReC, an intelligent dynamic range extension calculator. It is a special function in the SPD-M30A photodiode array detector. DReC is a new processing methodology used to drastically extend dynamic range. Conventionally, high concentration samples need dilution prior to injection. However, DReC provides accurate quantitation results and area percentage results without sample dilution. For saturated signals in higher absorbance areas, its calibration linearity can be improved by up to a factor of 10 with the automated adjustment of the calibration curve. This methodology can be applied to a wide range of analytical needs, including the analysis of trace impurities like genotoxic impurities based on FDA and EMA guidelines, or contaminants or hazardous substances during quality verification, purity, and stability testing. Let's look at the basic theory of DReC. With DReC, data produced by a PDA detector is used. If the peak intensity goes beyond the threshold, the DReC function will be activated automatically. The wavelength of unsaturated absorbance will be selected instead of the saturated absorbance wavelength. The unsaturated signals like area or height and their sensitivity ratio versus the original wavelength will be used to calculate the original area and height of the target peak. Next, I'll explain how to use the DReC function. Normally, a high concentration area makes the absorbance saturated. As a result, the area value cannot be correctly provided, and the calibration curve cannot maintain its linearity. In lab solutions, set the DReC function in the multichromatogram wavelength setting window. Simply check the dynamic range extension checkbox. Using DReC, even in the high concentration range, enables accurate quantitation results and provides a calibration curve with good linearity. DReC comes standard in the latest lab solution software. In this example, involving indomethacin, the linearity range is up to a 100 mg per liter concentration and a 2.9 AU intensity range without DReC. When DReC is turned on, the concentration range goes up to 800 mg per liter with a 23 AU intensity range. As shown, the dynamic range was extended by a factor of about 8. This example shows an area percentage calculation. Conventionally, when the area percentage is calculated, the dilution ratio needs to be considered to cover both the main peak and trace impurities. If the DReC function is applied to the main peak, an appropriate area percentage result can be obtained without the sample dilution process. In addition, by using DReC, there's no need to reprocess the data. The dynamic range can be extended in the processing window. Therefore, this reduces the sample preparation process. Also, it is possible to avoid the human error that occurs during the dilution workflow. The SPD-M30A high sensitivity cell has an 85 mm optical path length, and it boosts sensitivity by about 5 times. On the other hand, DReC extends the measurement range by about 10 times in the high concentration direction. So DReC, with its high sensitivity cell, extends the Nexera X2 measurable concentration range up to 50 times. This measurement can be performed using only a single PDA detector. This slide shows a calculation example of a drug sample using DReC with its high sensitivity cell. Using the SPD-M30A high sensitivity cell enables the user to detect small peaks like these impurities, but the major component peak may be saturated. DReC automatically corrects such a saturated peak height and area, and provides an accurate quantitation result. Here is a summary of DReC. DReC extends dynamic range using spectrum shapes and its ratio between certain wavelengths. This function enables simultaneous quantitation of a wide range from low to high concentration components. DReC uses a single channel from a single PDA detector, so there's no need for extra calibration using standard samples. It is also suitable for routine analysis because of its simple method setting. Utilizing these functions result in a more efficient workflow and more reliable data. DReC is a new solution that reduces sample preparation process times.
Excellence in science. Shimadzu.